After downinstalling Blender, we run the program and, in the Startup window, select the General option. In Blender's workspace, there are three default objects: a cube, a camera, and a light source. The names of these objects can be seen in the Outliner panel at the top right. If we want to start a new project and do not need these objects, we can select them using the mouse and then press the X key on the keyboard to delete them. To create a setup, we first need to define a ground plane. In Blender, when placing an object in the scene, we must consider whether its properties involve movement. If so, it must follow the laws of physics. Example, if we create a spherical object, by default, it is positioned at x equals 0, y equals 0, z equals 0, which means it is exactly at the intersection of these three coordinates on the 3D grid, the default scene. We can also check the precise location of an object by pressing the N key to open the Transform panel, where we can see its coordinates in the Location section. Since we aim to control the size, placement, and physics of objects dynamically using a Python script, we need to understand how Blender's coordinate system works. Blender provides a predefined 3D space with an origin point, allowing us to position objects with specific distances from the center. Before we start, there are two very important points to consider. The main purpose of this program, after creating 3D objects, is to move these objects. The environment we work in is a virtual space with no inherent motion or forces acting on objects. In this space, to move objects, there is a section called Timeline. If we want an object to follow a specific path, we must select the object and mark its start and end positions in the timeline. However, this object is non-physical and does not interact with other objects. It moves like a ghost, passing through objects without any collision. This is because the object lacks physical presence. If we want to give it physical properties, we need to assign it a rigid body property. Once this property is applied, the object is affected by gravity and can collide with other objects that also have physical properties. Now, the object is no longer controlled directly through the timeline but instead follows the laws of physics in the scene. The timeline now only controls time progression, while physics determines movement based on real-world forces. However, it is not as simple as it seems. When we press the space key to start the animation, if we have placed an object in a position where it relies on physics for movement, it will fall through the floor into negative z coordinates. This happens because it needs a ground surface to prevent it from sinking. All of these explanations were necessary because, since we will be working with scripting and relying very little on visual tools and menus, these fundamental mechanics might be hidden within the complexity of the code.